And here we go. Alright, let's see if anybody is here yet. Hope everyone is doing well today. Let's see if we can combine and consolidate. Oh, let me get this URL. I used to know what URL stood for. Now I don't remember. I used to know what HTTP stood for too. Don't remember that either. Alright, explanation. I glanced at this last night. We'll go through this, as always, like we normally do. So if you're new, just joining us, thank you for coming and hanging out with us. We do these live stream challenges to stay, just to let everybody know, we're probably going to do, I need to do a couple SQL. I don't know if we'll do it, because I haven't done a SQL challenge or written any SQL in well over a month, and that's probably not a great idea. So I started seeing numerous posts talking about, I know I'm staying up to speed with problem solving, but actually writing pseudo SQL code and going from there. All right. Let's see. Given an array of distinct integers. All right, so they choose words for a reason. Morning, Dax. Good to have you here. All right. So all the words that they use are they're not wasted words. So this is pertinent. Alex, oh my gosh, how are you? It's good to see you again. I'm doing well. How are you doing? Return an integer target. Aha. All right. Return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combination in any order. Okay. The same number may be chosen for candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. Test cases are generated such that the number of unique combinations that sum up to target is less than 150 combinations for the given output. All right. That's there for a reason. Don't know the significance yet. So, all right, candidates and target. Okay, so this is unique, but you can utilize, that's what it was saying. So, all right, so target is 7. We take 2, 2, and 3, and we get 2, 2, working the data muscle. Yep, I 100% agree. Because I started seeing that there's, and there were a lot of very cool jobs last night. So, and next Friday, I'm going to be on a live stream with, I'm going to be on another live stream. So, we may not stream for very long on Friday. So, all right. So, how would we begin to utilize this? This is going to be a lot. I hope Venki shows up because I feel Venki could help us with this math because we're going to have factoring because right now, I mean, 7, so this feels like a factoring problem. All right, here's the explanation. 2 and 3 are candidates. 2 plus 2 plus 3 equals 7. That's going to bother me. Note that 2 can be used multiple times. 7 is a candidate, and 7 equals 7. Oh, I missed that. Okay, I completely missed that. I thought that was the target, but yes, that's a great point. So, and then of course, if there was a 1, you'd have 2, 2, 2, 3, 1 and 6 in a list, and then 7. All right. These are the only 2 combinations. All right, example 2. Candidates 2, 3, and 5 target 8. And then here are all the combinations. 4 2s, 1 2, 2 3s, and then a 3 and a 5. So we use a whole list of so my brain is initially going, what numbers? Oh, it's a stream. It's a show. I might put the link in on Thursday. It's for Secure Nation. It's a lady I met probably 4 or 5 years ago, and we just connected on. She found me on through free code camp, and we've chatted a few times. And she's tried to get me on her. It's kind of like a podcast-ish kind of thing. No, I'm going to be streaming, and I'm just going to be a guest on her show. So, gonna try to, because I've always known, not always known. Once this job situation came about, I knew that my presence on the internet, YouTube and LinkedIn, that's more than likely going to be how I'm going to get the next job, because YouTube was how I got the first job. So now with the way the world is, I'm trying to be out there as much as possible. So taking phone calls, taking meetings, meeting as many people as possible, sending my resume to as many people as possible. Anybody who knows anybody who might need somebody who, because I got quite a few phone calls, three different phone calls because of my Data IQ experience. One was pretty close, one wasn't very close at all, and then one was a non-starter. So it was interesting. Sorry, thought I heard something. Let's see. All right. So what's coming to mind is we're going to kind of factor, but factor by sum. Like, what combinations can we get? And then if those are present, that may be over, because we'll get a bad score. So when I mean a bad score, I'm thinking about time optimization. So, I don't know. We're probably going to, and I need to end in about 75 minutes because I'm feeling better. So I'll be going to jiu-jitsu today, so I'll need to wrap up at about quarter past, get ready, and head out. So, excuse me. So candidates 1, I'm looking at example 3 here. Example 3, candidates, a list of 2, target 1, output is nothing. All right, constraints. Let's see if this is... Let me make sure. All right. Nope, no powers here. A candidate's length 1 through 30. Candidate ID 2 through value. Okay. And the target is 0 through 40. All right. So it keeps some constraints. And the candidates are distinct. They keep saying that, so that's important. Did I post on that I was live? There we are. Oh, and I hope everybody kind of enjoyed or liked what we did yesterday with the 24-hour clock. Did not have time to look at regular expressions yesterday to get to the bottom of that, but I hope everyone liked that. All right. Let's see. Let me make sure I have everything set. All right, here we go. Well, we got to start somewhere. So what I'm trying to avoid is multiple loopings through everything. And right now, because I know we can do, if we do factoring, but I've never done what are the sum combinations? So for 7, because if we had a target of 40, yeah, I mean the possibilities of adding to 40 would become, we have 1, 1, 1, 1, 1, we have 1 40 times. So yes, wait a minute, candidates. Oh, thank goodness. All right, so it's not it's not 1. All right. So if you're super new and you're like, how did you know that? So all right, candidates is the list. Actually, I want to make sure that I utilized, because I is the index. So the way that they write this is very, very brilliant. So they're telling us this for a reason, and I wanted to make sure, because we've used I before. We've had problems where we take I and J. I is the index and J is the value of said index. So that's what drew my attention to looking at this right now. So all right. So candidates in the index. So the values, the actual candidate. So we have candidate inside candidates if you iterate through. So I just wanted to make sure all elements are distinct. So, but that doesn't necessarily mean, because we're using, so if we got to, we need an odd and if so, what I keep coming back to is an odd and even and a combination thereof of sums. So, because we know that these are going to be distinct, the candidates. Let's just bring in the first one and see if we can even match the output. That's step 1. That's how I like to approach this. All right. Candidates. I don't think I've ever enunciated the first D. Candidates. Not can. I've always said candidates. Candidates. Interesting. I don't know if I've ever. All right. I'm feeling it. Odd and even is important. And then same candidates and target of 8. Let's get this down here so I don't head it. The reason why I want to keep that in mind is so I don't head in the wrong direction and miss out on anything. All right, so 7 is 1 plus. So this is going to be a list of all right, so let me come up with how I'm even deciding to do this. So I'm iterating through here, and I see, of course, 7. All right. So that becomes a list. A list of 7. One. Now, I need to is what I'm seeing here is I'm trying not to. So what's going through in the back of my head right now? Could we solve this with a SQL and merge operations? Let's see. How would not that I can see right now. I'm not saying it's not possible, but I don't, because we need to break. First, I guess I don't want to jump into coding yet. I don't even know how I'm making this. I want to make sure that I understand how I'm making the decision. That I go, oh, I have this 7 right here, and I came and I started with 7. And I go, okay, put that in a list. Then I have 6, but I'm going no. But the reason why I'm saying no is because then I would need a 1. But I would be jumping to the end of the list looking for 1. So that's very inefficient. So before we even get crazy, every sum combination results in merged with target. Okay. I think I see where you're going with this. There's the math. There's the math angle. So this is why I wish I was better at math. Candidates. Let's do. All right. Because no. I know where you have to start somewhere. So I know what you're saying. I had an idea of the angle in which you were going. It's going to be something similar adjacent to this for a elegant solve for the math side of it. Before that, we're just going to be, I'm trying to think of this elegantly to go through and not have to iterate, because what I'm trying to avoid, so it won't be 2 or it won't be, wait a minute, odd or even. That's going to be part of it. All right. So why do I say it's going to be odd or even? Well, because it's never going to be, the contents are never going to be, sorry, I thought I've broken that habit of me clicking that, because I now know why it's doing it. What am I saying? Odd or even? Because it won't ever be 1. What is that? Is that 1, 2, 3, 4, 5? That's 7. So it won't ever be this. So if it's odd or even, because I will have 2's all the way through, and I subtract So I'm trying to think of how many times, because if we look at this, we're having to iterate through this 2, 2, 2, and I'm thinking maybe subtract down the candidate from the contents. Because I already have 7, I subtract 2, I subtract 2, I subtract 2. All right, I have my target, right? Then I have target, decrement, candidate 0. And then I have target. I have 5. And that we need to figure out a way to control this. That's my first go round. And I don't love this solution. And I also don't love how much we're going to be iterating through this entire list. But there's got to be... But I mean, we're creating lists of lists, and we're constantly iterating through. And if we were to get this, but if we have a 40 here, but then how would we design this test? Well, actually, let me just finish that line of thought before I abandon it. So if you're sitting here watching this and you're trying to figure out what am I doing while I'm talking, or what are you talking about while you're sitting there thinking? All right. So I'm trying to sit here and think through how I'm really, we've done some videos on this. How am I actually, and what am I actually doing while I'm about to start programming this? Well, you can't program, you can't give somebody because I'm going to be giving my computer instructions to run. So if I don't know the instructions, if I don't know how I'm doing it in my head, I can't write the instructions. So I'm trying to decide the rules. Maybe we should use that word. I'm designing the rules of how did I realize that this is one list, and we're going to utilize these for the other lists. So would we do a test? I know we have modulo, but target minus, I just want to do this while target is 0. So what I'm trying to do is I'm trying to decide when to move on from here, and how. Let's use this 8. We'll comment this out. So this is a more interesting one because we're going to have more of these. So while target is greater than 1, because we need to come through here and go, okay, can I use this 2 to get to 0? That's our goal. And then, all right, but then my problem is, how can I get to, wait a second. These 2 are factors of 6, right? I think that's something. Oh, we have a different list. Oops. Let me get this candidate down here. I thought it was the same list. My bad. All right, so here we are. But also, never mind. Because you'd have 2 of these and 1 of these. But when to move on and go to the end of this. All right. And YouTube is acting weird. I think I'm still coming through, but it's looking like I'm not. All right. And I don't think this is a very exciting stream because no one is clicking and no one is coming to hang out. But we're going to do this anyway because that's the point of this, is to stick with it. And this is very, very weird. Now it's saying it's not coming through. Stream health is low. Well, that's not good. All right. So for candidate and candidates, while okay, so target temp target equals target. All right. And then while temp target greater than 0. So I'll walk you through what I'm doing here in a second. And then also, this isn't, I'm not liking this either. So I was trying to think, is there a way to iterate through this? But right now, if I were to iterate over here and go through, I'm not going to control how many times I don't know why the YouTube feed is pausing. How many times through? So all right, so this is bad. So what would happen is I would come through and get all the 2s, but then once this happens, I would come over here to get 3. So I've got to figure out a way to get combinations, permutations, distinct candidates list. And my only other option is to take target come up with all the combinations to create target, and then go back and look and see if those numbers are present. All right. So if I were to come through here, and how about we say I'm just going to do that. So this is garbage. All right. So I know how to do factors. I know how to get factors of numbers. But how do I get we may be finding a different challenge because I don't even know where to begin with this. And I'm just going to sit here and flail for an hour. But that might be good for me to do. All right. So the combinations for 8 are, well, we know it can't be 1. And there's going to be a list of lists. So we're going to do this. And there. And then 2, another list. 2. 2, 2, 4. Then another combination is 2, 3, 3. Okay, because what I'm doing right now is I'm looking for combinations so I can begin to devise an algorithm that can work. So right now 4, 4 and 4. Then, and I don't have a comma. And then 2 and 6. And then 8. All right. Let's look and see. So we can't have 1. So I'm thinking odd and even. So this is not that bad to come up with. Oh, I do not have a 3 and a 5. All right. And then a 7 and we can't have 1. All right. 2, 2, 2, 2. 2, 2, 4. So can we have an odd and even and a 2? Yes. A 2. A 3, a 3, a 2. A 2 and 3, 3. Okay, no, wait a minute. We already have that. All right. An odd and an even. So if we have an odd and an even, that gets us. So the way that I'm trying to do this is kind of come up with some sort of factoring process to devise this. And I don't know if to start at the lowest or to start at the highest. I don't know the answer. I don't know what the best practice would be. But we're going to figure this out. I haven't looked at the coloring in a while. All right, that's not too bad. All right. So 2, 2, 2, 2, 2, 4. Then some odd combinations. And we already split up one of these, same thing. Odd. And of course, then the higher we go, the weirder it will go. And then I'm thinking the combination for, now this does not seem like a medium problem. And I haven't. How would we even devise this? Because again, I don't feel like factors are easier than I would have never thought that sums would be easier than factors. Because factors took me a minute to wrap my head around, but then once I got it, how did I solve factors? I wonder if there's a Rosetta Stone in the factoring. Let's see. Let me make sure I unmuted Discord and turned on the volume. Okay, I did. Does anybody have an opinion? Did I miss any sort of combinations? Because I think this is going to be the faster way to do it. And then we just automatically come up with the combinations. But then we'd have to recheck and see if. Then we'd have to check and see if these are in here. That sounds awful. because then we'd have to look inside of each of these, then to iterate and see if each of these are in this. This is just getting worse and worse. But I mean, I don't even have an answer for this right here. I hope I don't get this as a question on an interview, because I don't even know how to write pseudocode to do this. All right, so let's just stick to it. This is like I said, get comfortable with being uncomfortable. So if I were to take all right, another iteration way. If I come here and I decrement this, and I continue to decrement, and I look for the remainder, is target in the list. So like if I subtract 2, so if I subtract 2 from candidate, is the remainder in the list. So, all right, so basically it would be if I subtract this, then I would make that list. So then if I subtract, but then how would I control that loop? How would I control the loop to know to move on? So if it's even or odd, then I'm going to, I feel like there's something there with even or odd. Hope Vinky can jump on, because I bet Vinky could just come and look at this and be like, I got it right here. And it's probably a very simple mathematical formula that I'm just unaware of, which is fine. So here, like this right here, I don't know for what reason that I like this. We have two numbers. We have two sets right here. We have two arrays. First one, both of them are even. The next one, both of them are odd, and then both of them are even. I don't know. There's something. This feels like this is telling us something. So we start here, then we come to here. We can't have 1, so you can't have 1 and 7. So then 5, actually, if we look at this truly, this would go here. And I'll walk you through why, because I'm trying to design a pattern and then this should go here. And I'll show you why, what I'm trying to design. And I look for patterns. So we start with 8, the highest, then 6, then 5, then 4, 4, 3, 2. I feel like there's something here. So can we divide? Can we factor these? That's what I'm looking for. I'm looking for some sort of pattern of how to do this, but then we'd also then have to catch if all of these are around. Because some candidates 10 some part of candidates. That's our first. That seems like that's important to this as well. Because we could go through and brute force all of this. I'm trying to find a balance between using brute force and how my brain is actually deciding what these factors are. So when I looked at this, I'm like, okay, I can do a bunch of 2's because this is an even number. Now I have an odd number, so I need another odd number. And then but now how can I control temporary lists and the candidates list? So why did I say that? What did I mean by that statement? So if I iterate over and I come here, and if I were to go 8 minus 3, and then I go again 8 minus 3, and then I'm down to 2, is 2 present? Yes. So if 2 is present, the remainder, I'm trying to figure out how can I get to this combination. So I iterate through the list. So it's some sort of decremental. It's either going to be an incremental or decremental, because my first guess of creating all of the combinations is going to be a no-go. And the reason why I feel it's going to be a no-go is after I create these lists, I will then have to iterate through each of these lists of lists and see if its elements is present in the candidates. So that's why I have eliminated that as an option. So now if I come through here and I iterate through here and I decrement all the way down to 0, and I create a temporary list and I were to get 2, 2, 2, 2. Now, wait a second. Okay, what pops into my mind is if the remainder is greater than or equal to here, starting at the end of the list and looking for the largest number. All right, let's go through here and let's what are we just doing? Output? Okay, out. We'll just do out. All right, so here's my first one. So I look at 8 and 5. So I have my target. Does 5 basically, does 5 go into 8? Yes. Then is the remainder greater than or equal to, no. Yeah. Greater than or equal to 5. False. So then I move over to here. Then, so I'm going to get rid of all my combinations here first. That's the way that we did this. Okay, so let's go through this really slow. Let's comment this out so nobody looks at it, because that's garbage. All right. I think they did this on purpose or on accident, because I don't think you can control this very well. So what I'm going to do is I take my 8, I'm going to subtract 5. Will 5 go in again? No. So I move to the next object. Will 3 go into the remainder? Why, yes. So then I'd have 5 and 3. And is it 0? Then I'll stop, and then I'll create a new list. So then I come over here. Does 3 go into 8? So it'd be 8 minus 3. and I'm here because we've already done a 3 and 5 combination. Will 3 go in again? Why, yes, it will. So then I'll go do one more time. Will this object go in one more time? No. Then I will ask, is the remainder in the list? If yes, add remainder to the list, continue on. Then we decrement down 2, 2, 2, 2, 2. All right. Now I'm going to try to get this out of my head because I think this will work. And just walk with me through this. So I'm going to start. So I take my target. So I start at the end of the list and I decrement. And then if there is no remainder in there, then we discard the temporary list. I think we have a lot more control when we do it this way. All right. So, don't know which is going to be first, the while loop or the... Well, I have to iterate backwards. So first one, because I did a lot of coding yesterday without any testing. So I need to iterate through the candidates backwards. That's what this is going to be right here. So for let's just do candidate in candidates. I need to iterate backwards. So if you've never seen this before, I'll go over it in just a second of what in the world I'm doing and why I'm controlling it this way again. Print candidate. All right. And 5, 3, 2. Okay. Candidates. So here I am. Vinkey, how are you? Man, we have been struggling without you. I think I fell backwards into a possible solution. So go to, there we go. Here's, there's that. But all right, if you're super new and you're like, what is this saying? So I'm saying start at the, what? Oh, yeah. Start at the beginning, go to the end, and go in -1 steps. So start, stop, step. That's what that means. So it's the same. If you can't remember, it's the same rule as the range function. Start, stop, step. So so I'm blank, but I'm handling the blank means go all the way to 0 at the start, and then blank at the stop means go all the way to the end. I don't have to know the length. If you want to do this the long way, it would be 0 : len dot candidates. 0 : len candidates : -1. So -1 is the steps. So I'm going in reverse. So I'm just saying print this out in reverse. So 5, 3, 2. So now, okay, so that is happening. So now I need, each time through, I need temp. So I need a temp. I need a temporary list. All right. Now, while, and then remainder equals 0. All right, so that's my leftover because I'm going to need to handle this in just a second. All right. Ooh, I'm stiff. I may need to get up and move around. I got about half an hour. I may need to move because if I have jiu-jitsu and I'm this stiff, I'm gonna die today. All right, so while remainder, let's just do R since I'm not sure. I don't mind embarrassing myself a fair amount, but I don't like doing it all the time. All right, so while R greater than target. All right. Then target minus. All right, so let me make sure. No. Target back to R back to target. So I'm reassigning this. And then I'm going to decrement. Yeah. And then I'm going to decrement R by candidate. All right, so greater than zero, not target 0. So then all right, nope, I fell apart. So let's kind of start back over. So all right, let's go back through this. So I subtracted 5 while R greater than candidate and candidate. I'll walk you through this. All right, so okay. So let's go through this. I have my temp variable. My R will be, we're going to start the first time, R will be 5, right? All right, so I'm going to take target, and then I'm going to reassign target. So watch me here. So I'm going to keep up with the remainder and this. So now R is 8. I lied. R is equal to 8. All right. So then my candidate is 5. So R decrement candidate should be needs to be 5 the first time. Let me start over. So R equals 8 and candidate equals 5. All right, so here we go. And so then I'm going to take R, decrement, candidate. So now, all right, so this is what I want to have happen. So I can subtract. So for us to, because I couldn't control how many multiple times, but if I can come through here, we're going to find out very soon if it works on this. Works on 7 and this list of candidates. So, all right, I want to subtract 5 from this. So let's make sure, and then basically I want to see, since R is going to be less than the candidate, we're going to do another test. We're going to come down here because basically we're going to add a list. So right here, temp. So can it go into, and then we need to take temp dot append 5. So I've added 5, subtract 5. Now R is going to be 3. So now we need to do something else. So we're done in here. if R in candidates, then temp dot append R. All right. And this should be candidate. There we go. All right. Let's throw this against the wall and see what happens. I don't have output. Out equals and then I get done with this. No, not that. This. Else. Okay. If it's not in there, so now we need to handle this because we're going to get partial lists and we need to make sure we're handling this. So what do I mean by partial list? So also if this is not in here, we need to wipe target. All right, so let's just see. We need to make temp equals blank, and then if temp len temp, I'll walk you through what I'm doing. I feel partially comfortable that this is greater than 0. Then we append output.append.temp. Moderately comfortable this is going to work, but we're going to find out here in just a second. All right, that worked a lot better than I thought. So what in the world did I just do to make this happen? Now, that was this scenario. Let's see if it'll work on these two right here, and I'll walk you through. You would think I'd be a lot smarter and I'd do print out right there. Dax, are you watching any college football today? All right, so we got a little bit of a problem. We fail this one. We only got 7. All right. So I lucked out pretty well here. We could probably clean this up. So let's go through candidates and then target. Now, why didn't I get any of the 3s and 2s? So we need to get a 3, 3, and a 2. All right, so this is garbage. Let's get rid of this. Let's bring this up here. Three, 3, and 2. So we're super close. We just have to tweak this a little bit. All right, so I'm at 7. I'm at 6. So I come through and I have the candidate is 7. I have my target and remainder is R. Let's print out R and candidate. Let's see what happens here and see what we're getting. All right. Candidate is 6. Greater than or equal to. Okay. Problem. So now we went from, all right, so we have our 7. Now I get to my 6. All right, so this feels like an order of operations problem. As I should have 6 shouldn't work, which we shouldn't get that. But why am I not getting 3? So when I come back around here, I should be resetting. Hang on a second. Oh yeah, there's Jesse. Sorry, we have a group chat for jiu-jitsu. So why isn't... So now I feel pretty confident. Well, we got it to work here. So, but I'm lucky because my last edge. So I'm getting 7, but I'm not getting. Vanky, do you have any? Just a busy day. Just came to check in. Oh, I guess Vanky probably already had to go. No worries. Let's see. Okay, one of the beasts will be there today. I'm gonna get choked a lot today. All right. Let's see. So I check 7. I hit my temp and my target. But if I go to 7, if I go to greater than or equal to, R is greater than or equal to okay. Nope, I was right the other way. That was going really fast. All right. So 7 makes it in. So I need to print so why isn't well, Nico, happy birthday today. I saw that you had changed your name on Discord to it's my birthday, so I was not quite sure if what that was. So, well, happy birthday, Nico. I hope you have a good rest of your day because I have a feeling it's probably evening or late evening over there where you are. So I hope you've had a great birthday, and I hope it finishes up very, very nice for you. All right, so see, why shouldn't, because this should go in, because we want 7 and that, so I got an order of operations problem. So I'm in a poor test. So when we go to here, we get all our nice little pretty combinations. So this is why it's important for edge case testing. 4:55 p.m. Okay, very cool. So you have a good amount of day left. Well, that's awesome. Got it. So let's see. I go through. So this one works. And this is what I love. So I designed it for this to work, right? This is why I love programming for a ton of reasons. But I designed it for this to work. And lo and behold, this works. And then I change my data. This is why testing is so super important. So then I change my data and I get a partial answer because I wrote it for this. So, but it's got to work in all cases. That's all cases, all situations. So let's get through right here. So I have candidate, I have target. Target is 7. I now reassign. Make a word chain program that makes a lot of chains. That might be pretty interesting. All right, I think I was talking, you weren't here yet, but I think tomorrow I might do some SQL on some of these platforms because I haven't written a piece of SQL in a while. And if when I start to get interviews, I'm going to need to be, we're problem solving here, but I haven't written, because just SQL brain is not Python brain. It's not human brain either. I call it compression, accordion files, where you take and you do some things and then you can make more columns, more accordions. But my really intrigue is the group bys. Really, not to speak down to SQL because I love it and it helped me learn a lot of things. But SQL is just basically compression and group bys, and then you get more sophisticated from there. But the real issues is aggregation and how to aggregate. And then it becomes like it's simple, and then it becomes unbelievably complicated because you can do some pretty fantastic things with rows and columns, some unbelievable things. And it usually takes a business partner to go, hey, I need to know this. And then you're like, okay, that's a really cool problem. Let's go do that together. And that's why I like it, is we're sitting here staring at the data and we're like, hey, what can we do with this? Well, we're not on the business side. So that's why I think it's very important to have a nerd partnered with a business partner, because you can really do some pretty cool stuff. All right, so let's get down to this because we're so super close and we have about 15 minutes. So I go through the first time through, I have 7. So does 7 go into target? And the answer is yes. 7 goes into the target. And then what will happen? That is you and not a dog somewhere, right? Yes. Okay, you printing stuff? Trying to. Okay. Actually, I was a little scared my wife was going to jump over here and scare me. So I think my daughter would have. Oh, is that somebody else in the kitchen now? Sorry. We're starting to get pretty active here. Let's see. So first time through, at least we have a working algorithm that finally is working. Vinky wasn't here to help me hold my hand and get me a pretty good solve here. So next time through, I don't know why it does that. I think that was a Facebook. Yep. So 7. So it doesn't go in here. So if R is here, it goes in. So else. So what we're doing, let's kind of walk through. So basically, we're going to subtract the candidate until it's not bigger. Okay. But we do want it. Well, okay, I gotta check. So am I reassigning the remainder? So this works perfectly because I didn't really care for my order of operations. Because I was thinking, but the 2 is still there. So then if it's not in there, then I re-empty the list. And then I do another test to see if, because I only want to append, oh boy, that's wrong. Because this will fail this one. Because I will not append anything. I can solve that down here. If output, wait a minute. No, that would be right. Output would be, okay, no, that inadvertently is correct. All right. Sorry, there's lots of people showing up today. I'm gonna get choked a lot. All right. So two. Oh, that's awesome. Thank you, Dax. We are so close to this. And I don't feel like we're wasting a lot of time, even though Leetcode will probably do that. But we looked the other day. Leetcode is having a problem with its timing feature. I'm going to check that right now. And it's still showing that I'm a genius and I'm taking like 3 milliseconds on a problem. There we go. All right. I don't know if Dax, or I don't know if Venky's still here. But it finally fixed everything. So I need to go and look and see what our last stream was and see if letter combinations for phone. Let's see how long this takes. Because it was saying that we were doing it in like 0 milliseconds. 36, man, it's not bad. Beat about 48%. Not great, but I think it's pretty good. Dax, I don't know if you saw, we did a letter combination one. And I was pretty intrigued to how we ended up. I finally did the first conditional for loops. I've never written one. I kind of wondered if there was be a use case, and that was so because in one case you go through and you just throw things in and you iterate. Who we could do those as. I bet if we did that as list comprehension, it would speed it up. Vanky, I think that's what we're gonna do one time, and we're gonna do list comprehension and not do for loops at all ever, because I've got to stop thinking about for loops and start thinking about list comprehension. I've got to move over and move past that. All right, so let's come through here. So I'm at 7, I get 7. I'm at 6, I've reset my target, reset my R. So my target is outside of here. I've reset R. So, all right, R, while R is greater than candidate, append candidate and subtract. So I get here. So if R, if not blank, so then I come up here and I should have 3. All right, so now here's 3. So why am I emptying? Why am I emptying? Because these should, I should have this right here. All right. Three, 3, 2. All right, so again, have an order of operations problem. Or is it, no, it should be this. These two right here. And I'm not getting this answer. So I should be getting, so I'm up here and I'm on 3. So I've reset temp, it's empty. I've reset R, so I'm on 3. So I'm at 3. And I've appended. Aha. I'm so close to why this is failing. Because we should be doing 3, 2. There's my problem. It's only looking for 2. This combination. Well, this should work because then it goes 2, 2, 2, and then looks for 3 in here. Because we just solved it for here, and we have 3s and 2s and 5s and 2s. All right. It's wrong because it's outputting wrong. All right, so don't get hung up on that, and don't let your ego go, why isn't this working? Well, it's not working. So find out why it's not working. Don't argue. Oh, that is such a video. Hang on. Don't argue with the code. Okay. So I'm taking, because it's 2, 2, and 3. So I get down here. So okay. So I get to the 2. Subtract 2. Because there should be 2 and 2, 2, and then 3. While R is greater than candidate, not equal to candidate. While R is greater than 0. All right, so my order of operations is flawed because I need to come. So I was doing this and then looking back down. I need to make sure that I'm looking at the entire list because this is the solution. 3, 3. So this line is wrong. So while R is greater than 0, let's try this. Okay, no. All right. You don't want to change and get too far off. So print temp. I want to see how close I am. Okay, 6, 3, 2, 2. Three, 3, 2, 2, 6. All right, so the design is super close. So it's working because it's perfectly not divisible, but because each of these causes a remainder of here. So, all right, so I've got to handle, because right here, the remainder should be looking for 3, and but how is it's here? If R remainder R minus R, if R in candidate R minus R, then boom. Oh, I'm so close, so close, so close, so close. All right, so follow me through here. So I like our algorithm. This just isn't matching our algorithm. So let's go back through. So I'm going to take this candidate, and will it, actually I guess we need to have, because what happens if we have a target here? Just got back. How are you doing so far? We're really close. We at least have a algorithm that is working. And I just realized an edge case. What happens if they give us a candidate list and this has it has 10 on it? And I'm just automatically assuming, oh, wait a minute. No, I'm handling this right here. But so Vinky, I think you would actually kind of like this a lot. So we're taking the last element, we're iterating through backwards. Here, let's look at this. Print candidate. We're iterating backwards, and we're taking our target and we're subtracting the candidate out of candidates while it is subtractable. And then if not, we're going to move down. So I got it to work here on this list. So I'll show you. But I'm not having it look exactly in the right location. I got some jumbleness right here. So basically what we're doing here is, let's comment this out so you know where I am. So here's our candidates, here's our target. What are all the combinations can we get of these numbers, our candidates, to create the target sum? So what I did is I started with the end, and then I moved over. So I subtracted the last element from candidate. So also I did it as if it can use and subtract itself. And I'm going down. Now the problem is when we get to here on 2s and 3s, because what I need is, well, no, that should still, we're going down this way. 3. Oh, it's 3, 2, 2. But that should be, that's what I thought I was doing, is that go take 7, subtract 2, and then the remainder, is it in here? If it has a remainder, then work. But apparently I'm going directionally, only looking down the list, and that's why it works for 8 and this set of candidates, where right now I feel like right here these instructions are not following this, because if you look really close, I'm really close on, let's go back, and then probably after this take a peek. Yeah, I got a wrap after this, so let's comment this out right there. And boom, here we are. So right here, I'm getting a 7 output, and I should be also getting a 7 output and a 2, 2, and 3. Don't know why. Oh. Well, wait a minute. The remainder, 7 minus 2 minus 2 is... is 3. But I'm also checking, can it be subtracted? Can it be subtracted again? All right, so this flow, no, this is completely flawed. Because is the remainder in here while we need to do a remainder? Okay, so maybe we will not be solving this. I thought I was really close. Because what the problem is, since this is not divisible, huh. Alright, well, I'm stumped. Vinky probably already has a solution. Alright, it's 17 after. I need to wrap everyone. Alright. We were super close on this one because my design is flawed. Oh. If it's not divisible. So we're going to straddle back and forth, subtracting and not divisible. Because then it needs to not look at it. So right now it's looking at itself. So I need to do another check. So if it can go into it, so all right, I'll explain this, and everyone can tweak this. This needs to only subtract in this instance if the remainder or the end result is going to be 0. So it subtracts. So my rule right here is if it can fit into, subtract it again, where it needs to go in one direction, go down the list, which is what we're doing here, or then if it's not evenly divisible or subtractable, else in candidates, something like that, something really, really close. Then it has to look on the last time. If it's not going to be 0, it needs to look up the rest of the list. Right, we're already doing that here. You're really, really close. I think I need another step here. Only to subtract it on the last time if it is, I would then need to look, because of course it's going to find itself, because it can, 2 can go into 3, because right here the remainder is equal to 3, but if I subtract r, or what would it be? What am I trying to test for? False. Then it would look at the rest of the list. So then it would look for wherever I am. So we need to change this to index. So then it would look at this section of the list, because that fits in. So if this isn't true, if this isn't true, then it looks at the rest of the list, and then I would hit 3. So I'm saying look in the list, but I'm looking at the whole list. I need to chop this down to here. I'm close to that. All right, so I need to go. Yeah, I need to wrap. Thank you, everyone, for coming to join. Hope everybody got something out of this. Make sure you're jumping over to the Discord to get the help that you need and deserve. And as always, everyone, thank you for joining, and I'll see everyone tomorrow. Bye, everyone.